Welcome to another episode and video on my Raspberry Pi 1 running Raspbian Linux, programmed in C and connected serially to a Minicom tonal program and with band cable to this breadboard with electronics. And you see two chips on the breadboard. First, here is the analog to digital converter, which I used in the reading of analog devices, analog sensors. And now I have added this chip for I2C communication. Because that would be possible with the Raspberry Pi, since it has two ports available for I2C. It's all wired up now, but as yet not working. And that is a little bit of a problem, of course. The problem is that it is not very clear how to wire it. Which direction running from 0 to 8, or from 1 to 8, 0 to 7. And also, are the used resistors the correct value? Then, upon studying the algorithm last time, I had to make quite a few changes. Also made a few errors myself, but everything in the algorithm should be working by now. So if I start the program, things should be working. Were it not that it doesn't. It would be a walking light, 3 LEDs, one after another, in whatever direction, but they don't. And I had them from 1 through 3. So in the end I figured, well, maybe it's since there are 8 originally, let me go from 5 to 8 and then back from 8 to 5. Didn't work either. So now the challenge is how to make it work. Do I have to add software? Do I have to rewire? Well, I don't want to rewire actually, being that the wires are quite fragile. The oscilloscope is a nice check mechanism, and right now data is set plus and not 0 or negative, but as yet I do not know if that is correct and what is correct anyway. So having found that the program doesn't work, I will dive deeper into both hardware and software. So I have now one resistor which is slightly smaller in value than the ones in here. So what I am going to do is replace these resistors, or at least one of them, and see whatever effect they have. And I have to be a bit careful with this, and this should work. So and now of course LEDs have to be in the right correction. That doesn't work. So let me check the software, change the software back to how it was, and then see how it ends up. I like challenges, and when you come to realization that the software that is provided is not really written for quite my version, it gets nicer. So let's continue. So now we are looking at results that are nice on screen, but without really visible results here on the board. Doesn't mean anything. Also, this is quite static right now, clock and data. So in order to check if the resistor change does do anything, let me change this as well. And then I'm in the code. So from it says move left and move right, but what is left and what is right anyway? So I'm going to change this back to 1 and this to 3. Yeah, well, 0 and 3. That I will have to save and make all. Alright, then run. Any change? None. So that was not a solution. If it had been the solution, I would have replaced all resistors, but not so fast. Then what could be it? Well, if you look at this website where I took the stuff from, then they come with some other ideas, and let's go up a bit, because they are talking about the Rev 2 board, revision 2, and these pins I am using just as well. And nothing is working as yet. Now, what is this? Well, this is actually the way that the GPIO is being controlled, and the GPIO is actually now this. So would I have to do the same thing? Big chance is that I do. So how to do that? Good question. Let me look at the part of the code. They say, okay, include a lot. So I think I should include those as well, the same way. The only thing is I can't copy between this screen running on the computer and this part running on the Raspberry Pi, so I will have to add that manually. So include, and include what? Oops, not that one, this one. I2C BCM 2708. I2C BCM 2708. And the question is, do I have to add just like this, or with an .h for header, and I2C hyphen dev. We'll soon see. Prepare for errors. in compiling. Yep, no such file. So .h and .h. Now let's see. And nothing. Nothing either. Then let's look here. It does have this header file, but it doesn't have indeed other stuff. Oh wait, it has PI header. Oh wait. So let's exclude this one and exclude this one and add no. That is better. And include pi underscore I2C .h. Another one is there as well, but let's try this one first. Yes, hold on, I make a mistake. I should include here a quote. This is better, but does it work better? That's a very good question. Let's check. So let's try to run it actually. Well, nothing happening now, so I'm going to do something different because it's now 03 again, and to make it easier for myself, this one like this, and this is 5 to 8. And the same procedure right here. So excluding this one, changing this from 8 to 5. So all I have to do is now bracket and no errors in value. Is this working? Well, software is working, but hardware doesn't do anything. So that was not the solution. What do I have any further that I may include? PIHVM. I have no idea what that means, what that includes. In, out. I think I can just as well not use it. This I would have hoped that that would be doing something at least. I2 init, select device, int fd. Look at that. It's using an integer fd. Now that's interesting because here someone is telling to change fd right here, and fd is used nowhere. So where should I use it then? So I can also try sudo I2C detect. Let's use that as well. Sudo I2C detect -y0, command not found. Am I surprised? Not quite. Oh, I2C detect, yeah. I2C detect not found, command not found, yeah. So not everything works as smoothly as can be. Now if I change the directory, not found, okay. And this makes it a bit harder because, as you can see, it is all from, well, by now 8 years old. Things have changed, new Raspberry Pi boards have been released, and this is not being updated. So this can be quite a challenge, and it already is. And what is the difference between this file and the file I'm using? Also quite interesting. So this is the demo file. What does the other file look like? Look here. Quite different. Quite different. Let me run this one. Is it already a program? I don't see, because I only see here a demo as being a program. What does makefile show? It does make a header file. It does make header file, and it compiles this one. But it doesn't say which output to create. Oh, here it does. Right, interesting. That means that I'm going to change the makefile, and I'm going to add that it indeed also makes the normal file. So interesting how that works out. Alright, I've made the following changes. First, I added normal file with all, clean up every object file and the old file, which already was done here, but I added the normal one. The ordinary file, I made an output file and then more or less copied the rest, excluding then the demo file, because it was already done here. And for the rest, actually nothing at all. Well, yeah, I added this part. And am I forgetting something? Probably, because I see here pi_I_C header, and I did not include that one. I2C.header, and header is HEADER, not header. So this should be it. Write and quit. And now let's make. As in make all. Missing operator, where? Line 33, which is right here. Which I added. I am somehow missing an operator, but I do not know where or how. The only operator that is here is -O, but that's the same as here, and yet it complains. Oh, wait, I already noticed. 0 should be O. Right. New attempt. Again. And this is nasty about debugging. This is output. This is exactly the same. No operator present. So should I have done something here? No, not really. I didn't touch that one. Neither did I here. Well, yeah, I added here MCP 23008. Here the same, with complaints here. And why, I unfortunately can't tell. So I have to study about that for some more. So let's do that on screen. Right, taking some time to study the errors made clear that I have made a mistake right here. Removed all the comments again, and my last attempt was nothing to be done. So let's run it again, make all again. Now let me see what has happened. Do I have a nice executable? I do not have an executable for MCP 23008, only for demo. That's a bit of a disappointment. One last time, how do I get it? Output, make it, because here an output file is being created, here an output file is being created, and I did change the sequence in which I do it according to this. So now this is the same sequence as here, and still no output file created, unfortunately. Can I do it manually? Well, yes, I could. Will that work? We'll see. Minus O, and let's see whatever happens. Alright, and so that is not really working right now, and I'm getting out of time. So unfortunately, despite adding stuff, it's not working out. Will this work out for the demo? Let's see. No, not really. So that has to wait for next time, I'm afraid. So, final part to end this video. Unfortunately, this is not working yet, and it looks like that I have to change and tailor everything to suit the needs with this chip combined with my Raspberry Pi version. Does this still work? Well, only one way to find out. It is in Python, not in C. And of course I have to test it in another way. So does it run or doesn't it? No, I have the wrong program, unfortunately. And this does work. So here's the pulse modulation with a LEDs, and this one still works, and everything else does as well. I just have no second fischertechnik LDR here, because this is just spontaneous test. but it does work and this doesn't yet. Anyway, that's it for now. Lots more to be done, I think. Thanks for watching. If you like this video, please subscribe to my channel. Give a thumbs up. Leave a comment. Ideas, whatever. You can also follow me on Twitter. If so, retweet and like, leave a comment. You can also follow me on Instagram. Like and leave a comment. Please donate to keep videos coming to you. More information on my website, and you can also become a patron and have your name mentioned depending on the pledge you make. Being either on my website or on my website and with the videos. Again, more information on my website. And this is obviously going to be continued. Bye bye.